All right, we have a quiz on recursion tomorrow, and I'd say the hardest part is understanding the difference between how you're supposed to put in an equation for growth versus decay. And I'm going to give you two scenarios. One starts with 100 and then goes down to 60. The other, and then it keeps going from there. And I can tell you this is a decay problem. It is not a subtract 40 question. It's a decay problem. And the other one is 100 and then going up to 120, ... And that is, again, a growth problem, not a arithmetic kind where you're just going to add 20. It's not like that. You're multiplying by something. So you need to find for me three things. Number one, you need to find the common ratio. That's the ratio as in you divide two things. Number two, I want you to tell me the equation that you'd use to put into your calculator to find the fifth term kind of thing. And that's specifically what we're doing, is try to find me the fifth term. And the third thing is find the fifth term. I want to give you a reminder. If you're doing a problem like this and you're asked for the fifth term, you should use u sub 1 to start with. All right. So number one's three questions are exactly the same as number two's three questions. So get your iPad out and give this one a try. This is problem one. Problem two. Figure out the common ratio, the equation for it that you'd put into the calculator, and then find the fifth term with your calculator. I gave the suggestion you should start with u sub 1 because they're asking for the fifth term. I'm going to pause for a second while you work on that. Okay, we exchanged iPad spots now, so we're going to see how the person did. Common ratio, you should have done 60 divided by 100. If they wrote that, that's okay. If they made it a decimal, it's even better. 0.6. Raise your hand if your person had that one right. Okay, good. Next one is the equation for it. The equation, you go un equals, first of all, you go u1 equals 100. Then you say un minus 1 times, now this part right here is supposed to add up to that, but it's supposed to have a 1 plus or a 1 minus in it. So it should have a 1 minus 0.4. And if you got that wrong, it's okay, because you're getting it wrong today when it doesn't really matter. What matters is if you don't get it by tomorrow. Okay, now let's make sure you get this. So this is the common ratio, but what the heck is that then? What's the 0.4? That's the decay, what? Rate. The decay rate is 40% on this one. That's a decay rate of 40%. And the common ratio is 0.6. Okay, then what is the fifth term? To keep me from having to type all that into the calculator, you guys, I'm sure you have it. What did you get? Your person had the number 3. What's their answers? Say some answers. 2.56? Everybody agree with that, or is that wrong? Okay, what do you think? What? 12 point something? 12.96. Raise your hand if your person said 12.96. That's most of the class. All right. I can double check that if you think that's wrong. Okay, good. Number 2. Number 2, the common ratio. You take this divided by this. Some of you are still talking. Stop it. 120 divided by 100. 120 divided by 100 is okay for a ratio. You should really reduce it. But anyway, I'm going to get a decimal. It's easier. 1.2. That's the common ratio is 1.2. Next, the equation. U1 equals 100. UN equals UN minus 1, and then you times by something that would add up to 1.2, 1 plus 0.2. That way we've got the common ratio here, and we got the rate there. The rate is 0.2 or 20%. And the fifth term on this one, it goes up, so it must be bigger than 120. What is it? 207.36? That sounds like it's being verified. 0.36. 207, if their rounding is off a little bit. I didn't tell them where to round to, so don't worry about it. Okay, give them a score out of 6. How many just graded one that was a 5, a 5.5, or a 6? All right. How many got one that was a 4, 4.5? 4s or 4.5s? All right, good. Thank you. All right, everybody, back to your own seat. Yes? Yep. Okay, just for a reality check for you, only the people with a 5 or a 5.5, sorry, a 5.5 or a 6 would have gotten a really good grade on this. Because a 5 is an 83%. That's not awesome. Most of you aren't shooting for low Bs. Okay? So, if you had something wrong, check it. Try to figure out, do you understand what you did wrong? If you have any that you want to debate, I would be willing to talk over. Maybe there's some other way you could have answered it better or whatever. Any thoughts? Any questions? Sure. Let's do one more to kind of finish it off. Let's say you had 60, and then it goes up to 70, ... Okay? Now, I'd like you to figure out for me what the common ratio is. Number 2, just put it into the calculator, and you should be able to tell what that 1 plus or minus thing is. That's the part that everybody gets wrong. Okay? Try to figure out what you should do inside this deal. 1 plus or 1 minus or whatever. Figure out that part of the formula. And last, number 3, try to figure out what the fifth term is. And I know you're going to have to round this. It's okay with me if you round to like 2 decimal places for your common ratio. I'm going to ask you one more important question that I think might be, some of you might have a misconception on. And that is, what is the growth rate? Because that's different than the common ratio. The growth rate. It's an easy question if you know what you're looking for. Got an answer or a question? Go ahead. So you want to practice one with the K? Yeah. All right. Let's finish. I'll do this one quick then. So this first one, when you divide 70 divided by 60, again, you've always got to take the bigger one, or the second one, sorry. The second one divided by the first one, you would get 1.166666. So you could round that to 1.17 probably. Now some of you probably didn't round it up, you just round it, you cut it off to 1.16, then you'll be just slightly off because of rounding. It's not that big of a deal. Okay, next then is number 2. You would go 1 plus, and then depending on what you said, I would go 1 plus 0.17. Then the reason I have you do it that way is because that tells you the growth rate, the last part. The growth rate's right there. It's growth of 17% growth. And by the way, when you're typing in on your Schoology quiz today, you're going to have a little practice quiz in class. They're going to ask you for the growth rate, and you're not going to know, do I type in 0.17 or do I type in 17%? It'll accept either version of the answer. The decimal is fine, or the percent is fine. And then the last thing is, what is the fifth term? Miss B, what did you get? Anybody verify that? A lot of people. 111 point something? Now, if it's off slightly from yours, could it be because of the rounding? Yes, that can make a big difference. Okay, so if yours was like 112 or something, then that's probably it. Okay, now I was asked about doing one where it shrinks. Let's do one like that. Let's say it's 200 down to 180, ... It's going to keep on shrinking like that, that same rate. Again, this is not one where you're subtracting 20. That would be called arithmetic. We're doing a geometric kind where it's a decay rate. So I'd like you to figure out the common ratio. Number 2, the formula. Number 3, or regression equation. Number 3 is figure out the decay, or no, figure out the fifth term. And figure out, number 4, the decay rate. All right, when I divided 180 divided by 200, I got 0.9. 0.9 is the common ratio. That is not the rate. That's different. Formula is U1 equals U1 equals 200. Why am I using U sub 1 all the time? Because I'm asking you for the fifth term. If I was doing a real world problem about like investments or loans or something, I would be using U sub 0. Unless they gave me a year, in which I'd be using U sub the year. All right, U sub 1 equals 200. U sub n equals U sub n minus 1 times, and I just realized I did all my formulas wrong on the last page, but now just with a little tiny thing. Anybody know what I'm talking about? I'll tell you about it in a second. All right, U sub n equals U sub n minus 1, and then I got to go, this part right here has to make a 0.9, except I have to do it with a 1 and a plus or a 1 and a minus. So to make this equal 0.9, I got to go 1 minus 0.1. And therefore, I now know the rate. This decay rate is right there, 10% or 0.1. And the last thing is the fifth term. And if I extend this out over time and just keep on doing it, what's my fifth term going to be? Yes, sir. Can anybody verify that? A lot of people. 131.22. Awesome. Okay. Any questions about that kind? Anything? All right. Now let's do some real world scenarios, which means we're going to change it to U sub 0 on your calculator. Yes? That is the part that I said I was doing wrong, and it's because you don't really need it. Like the calculator doesn't need the domain, but on the test, and I'll remind you of this, on the test you need to have the domain. And the domain is that n is got to be greater than or equal to, do you know what I do on this problem? 2, because it's always 1 bigger than that number. And it's really easy to forget that because it's not necessary for the calculator, and it's just kind of like an extra little like legal jargon, like this isn't really going to work unless n is greater than or equal to 2. It's kind of like at the end of the commercial where they are selling the cars, you know, the APR rate is 423%, and you're going to really be screwed over if you buy this car. Anyway, they say the things really, really fast at the end that you're not really supposed to hear, but they have to say them legally. So, anyway. Okay, so we have 1, 2, 3, 4 problems there. Who would have gotten a 4 out of 4 on this one? All right, good. Now let's do some real world problems where I'm going to give you a scenario and you're going to type it into your calculator. You don't even have to write the formula for it. You can just type it right in the calculator. Okay, so get ready. Here's your scenario. You have a loan. You're going to borrow $20,000 from your neighbor. $20,000. Has that ever happened? Yep, I know somebody that had that exact situation happen. And if you're going to pay them back, it's also polite to pay them some interest on the money. Instead of just giving them their money back, you give them their money plus some interest. So let's say a friendly interest rate would be like 4%. So if you have a $20,000 loan and it's a 4% interest on that loan, and you made payments of $2,000 per year, how much would the loan balance be after 5 years? I'm going to say that again. We have $20,000 borrowed. We have the interest rate is 4%. That's an annual, once a year interest rate. Next part is you're making payments of $2,000. Now, do you remember on the formula, all you do at the very end after the 1 plus the 0.04 or whatever, you just have to say the payment amount at the end. But is it a minus or a plus? It's a minus. It's a minus 2,000. Why? Because you're dropping your loan amount. You want to pay it off, right? You want it to go down. So you subtract 2,000 for your payments. All right, go ahead and get that into your calculator. If you don't understand, then pay really close attention to when I tell you the rest of the formula. So it starts $20,000 loan. You're making 4% interest rate, and then you're making payments of $2,000. How much would you still owe after 5 years is the question. First thing, did you start with u sub 0? If you didn't start with u sub 0, you messed something up already, because in a real world problem, you want that puppy up there to be a 0 on a real world problem. That top line on the calculator should be 0. Then u sub n minus 1. And then after this, I have 1 plus, and in this case, they did not say it was monthly payments. It was just one payment. So you go 1 plus 0.04. Do I need that divided by 12 in here or not? No, because this is not monthly payments. I'm going to get the divide by 12 out of there. And now, oh wait, I needed that end parentheses there. Inserting a end parenthesis. Okay, then the last thing is I'm making payments of 2,000. Should I add or subtract that 2,000? You are correct. Subtract 2,000, because we want the big the $20,000 deal to go down. Minus 2,000. Down here, I have 2,000. I should have 20,000. That's the original amount, the starting amount. After 5 years would be, quitting out of this, u sub 5 years. 5. You still owe $13,500. How come, if you've paid it down for 5 years at $2,000 a year, that's $10,000. How come you still owe more than $10,000? Interest. That's why banks make money. Okay, if this was a bank, the bank made, over that 5 years, they made $3,500. All right. So now, I want you to run an investment scenario. They're more fun because they're you making money. Imagine for a moment that you worked really hard this summer and you made $2,000. It is doable. It would be a challenge, but you could make $2,000 over the summer. A bunch of babysitting jobs, mow a bunch of lawns, whatever it took. You saved up $2,000. and you stick it into a investment account, like you can get at Scottrade or at Wells Fargo, or one of those places where you can invest money in stocks. And it's legal for you to invest money in stocks at your age. You can do that. So if you might have to have a parent sign off on getting the account open, but anyway, you make $2,000, you put it in there one time, and let's say that for some reason you get really busy and you completely forget about having that money in there. And let's say that you've invested it in an average portfolio of stocks, something called a mutual fund, which is like a whole bunch of stocks. You buy a little tiny amount of a whole bunch of stocks with that. And then some go up, some go down, but on average, the stock market has averaged about 9% per year over like 50 years. So let's say that your $2,000, you completely forget you even have it. People do that all the time. They're called forgotten accounts. There's even a thing at the state of Minnesota where you can look up and see if you have forgotten money. And you can't just take other people's forgotten money. I mean, that'd be nice, but you have to prove that you're the person that has the account. But that stuff happens. Like my dad passed away a few years ago, and what if he had an account and he was older? What if he forgot about an account? Just totally forgot he had an account at a bank. I mean, he had a bunch of accounts at a bunch of different banks. So what if we didn't ever notice one? Sometimes the money just sits in there forever, for like a long time, until somebody finally realizes, oh my gosh, that's my relative's money, and I deserve to have that because I'm the heir of his estate or whatever. Okay, so if your $2,000 sat in there for the next 50 years, 50 years, earning 9%, I want to know, when you are, let's see, 50 years from now, you would be about 65. Pretty much time for retirement. That'd be nice to have a little surprise of some big amount of money in there. $2,000, no payments now. Don't forget to take off the payment thing. You're not putting in any money or taking off any money. There's no payments. So on the formula here, this part, you don't have that part at the end. The 2,000 you're putting in is at the very beginning. U sub 0 equals 2,000. I hope you realized it was a real world problem, so you should be using U sub 0. Now, I hope you're getting a pretty big number for that if it goes by 9%. Who's got the number? 50 years. That's going to be U sub 50. $2,000 up front, 9% gain. 50 years of it growing. This is a real test question. Okay, so I get some feeling some of you aren't like, I'm serious. I want you to try this. All right, then I'm going to pair people up and see if your answers are the same. You three look on with each other. You two, you turn around and share. You two, you two, you two, you two, you two. Can you just share yours with hers? You two share and see if you got the same thing. You three. You two. Paying attention, guys? You two. You two in the back corner, and you two. One second. All right. We're done with that one. Let's move on. How much was it, by the way? $140,000. $148,000. Yes, and otherwise your decimal's in the wrong spot. Okay, $140,000. That's a lot of dough. All right. I want to also give you a feeling for how much you can save over the long haul, because that was just you working for one summer, putting it in and forgetting about it. Don't you think that between now and then you might save something else? Let's say now we add in a payment of, you know where that goes? After the parenthesis at the end there? Add in a payment of $2,000 every year. Now that's going to be easier and easier as you get to be an adult. Like for instance, a starting teacher, which I know you know doesn't make a ton of money. Starting teacher makes like $32,000. You can afford to save $2,000 if you've got a professional job. Okay, if you save $2,000 every year, I think you'll see that the amount will grow a lot. 50 years, U sub 50. All right, so notice this is not a minus 2,000, it's a plus. Why? Because we want the amount to go up. As opposed to a loan balance, like if how much you borrowed, you want that to go down. This we want to go up. And then if I go out and see how much would that be, U sub 50, you should have had, I think I did something wrong, sorry. Y equals, let me see what I have wrong here. Should have 2,000 right here. And something's wrong in my formula. 1 plus 0.04, oh, there we go. That's only 4%. Be a lot better if I got, what did I tell you to use, 9%? 0.09. All right. Plus 2,000, enter. And then I hit quit. And then I hit enter, and it'll just redo use of 50. There we go. Look at the difference. Holy smokes. $1.7 million. Almost 2 million, you could almost round it to. Okay. 1.7 million. All just by saving, or all just by putting away $2,000 into it, not just the bank. If you just put it in a bank and you don't invest it in stocks, a bank would only be like 1%. Not even that. Let me just show you the difference. This was assuming the stock market averages 9%, excuse me. 90 be great. 9% over 50 years. Let's just see how pitiful and small it would be if we change it to only getting 1%. So go into your y equals screen, change that to a 0.01 for the percent. 1% instead of 9%. Now I just hit enter and it'll redo the same calculation. It's only 132,000 instead of almost 2 million. 132,000 is enough to buy a very small house or a very expensive car. And 1.7 million is enough to buy a very nice house and a couple of very nice cars and still have money left to go out on a vacation to Hawaii. So the point is making money on your money and investing it somewhere where you'll actually make a decent amount of return on your investment is smart. Because it's not just like a little difference. It can be the difference, a huge, huge difference. 10 times more money, to be specific here in this case. More than 10 times. Okay. Last one I want to do is a comparison. And you're going to have one like this on your Schoology quiz too. So everybody go into the y equals on your calculator. Do you get that I can have another sequence on this same screen? You remember how it used to say y1, y2, y3, and used to be able to compare like 3 graphs, right? You can do the same thing with sequences. So we've got u sub n. When I move down to here, that says v sub n. Do you notice that? So you can't type u sub n minus 1. You got to type v sub n minus 1. So everybody put in a v. It's right above the 8. V sub n minus 1. End the parentheses. Times, same thing, parentheses, 1 plus, and we're just going to compare 1% and 3%. So 1.03, 1 plus 0.03, and then we're going to add that $2,000 every year, just like we did. So this is a fair comparison. One person's getting 1%, the other person's going to get 3%. And let's just see how much better it is. $2,000 to start with also. And then you're putting in $2,000 per year. Now, where am I going to see this comparison the best? On the table. Any of you that have the new Nito calculators that have 2 different colors, they graph the one table in blue and the other one in red. Makes them really easy to compare them, but it's not that hard to compare them just with your eyeballs. All right. Which part of the table were we at before? Okay, then you didn't type V sub. Okay, then you screwed up something else. Look at it closer. Compare yours with somebody else's calculator that is working. All right, here's the key. Go to table settings, go to table start at 50, and then go to table. And it might take a while to load because your calculator has to recalculate every single cell in that table all the way from 1 all the way to 50. So that's a lot of calculations. And it doesn't have to do it for just one sequence, it has to do it for both sequences. All right. So this is the difference between a person making 1% or a person making 3%. And the difference is about $80,000. That's why some people, more than 80, isn't it? No, it's more like $100,000. Yeah, it's about $100,000. So do you see why some people shop around for their rates to make sure that they're getting the best rate possible? They look at their mutual funds and decide, gee, I only got 4%. My neighbor guy's getting 6% on his. Maybe I shouldn't leave it in there. So if you're smart to kind of make sure you're trying to get the best rate you can. Because a difference of only 2% difference made a $100,000 difference at the end. That's a lot of money. 100,000, just for perspective, it's about $50,000 to take a trip around the world, as in fly on really nice airlines and sail on really nice ships and go to all these cities. And you could do that trip for two like that, just on the difference, 2% more on your investments over time, and you could take an amazing trip like that. Or you could say, I'm going to buy myself not a Lamborghini, that would cost you way more than this, but $100,000, you could buy yourself a really nice Beamer. Okay. A nice Lake Minnetonka yacht, not the biggest one out there, but a pretty nice one for $100,000. All right. So I wanted to run you through a bunch of practice problems like that because those were just like what you're going to experience on the test. And now you have two parts to your homework. I am going to work you hard tonight, but then tomorrow I'm not even going to give you any kind of homework at all. No 2-minute teacher things, nothing. When you're done with the test, you're done. But tonight, it's extra difficult. I'm sorry, but it is. It's do a Schoology quiz in class. So that's what I want you to do for the last 15 minutes. You probably finished the Schoology quiz in class. Then at home, your homework, I want you to do that whole worksheet. There's answer key with that's posted, of course, to check it. And I'm warning you, I haven't put in homework in a while. What I'm likely to do is have you put it up on your screen. I'll walk around and look at you, make sure you did your homework. Because I really want you to do it, because that means you'll be well prepared for the test tomorrow. Okay? Yes. So bottom line is do your homework tonight. The Schoology quiz, I'll know whether you did that even today because it'll show me the scores. So get your Schoology quiz rolling. It's called Sequences. It was assigned today. If you look under the updates section of your Schoology class, it'll show you where it is. And that's all I have for the video for